So welcome back, my beautiful students, to the final part of our ANOVA 2-factor screencast. So we've just made a note for ourselves, and we've reminded ourselves which are the formulas that we have to use to calculate the test statistics, as well as what we have to do, how we're going to get the F critical values. And we also reminded ourselves that it only has one critical value for each of these hypothesis tests that we have set. So looking at our questions, we'll see with factor A, and we know that factor A is the earnings brackets, we need to state the null and alternate hypothesis. So the null and alternate hypothesis in this case would obviously be comparing the earnings brackets. So let's just get our pen. Okay, pen selected. So for factor A, the null hypothesis would be the mu, because remember this is what ANOVA does. That's level 7 is equal to the mu of level 8 is equal to the mu of level 9 is equal to the mu of level 10. And so the alternate hypothesis for this could be the mu is not equal, the mu of level 7 is not equal to level 8, is not equal to level 9, is not equal to level 10. But I personally prefer to say that mu's of all levels are not equal. And the reason why I prefer that is we might have a situation where two of them are the same, and those two are not the same as the other two. But we don't know that because we're not testing that. So in my opinion, this is a better way to state it. But in many, many textbooks, I have seen them express the alternate hypothesis as is not equal to, with a not equal to sign between each of the groups. So that would be the answer to question 1.1. If we determine the relevant test statistic, we'll use our formula there. We've calculated what MSA is, and we remind ourselves, we also calculated what MSE is. So the relevant test statistic would be F test, or F stat would be 312,018.2917 divided by MSE, and MSE is 1037.9271, and that will give us an answer of 300.6168. So the next thing for us to do is to get the critical value. Now, to get the critical value, we're using the F table at this alpha. So it is important to select the table at that alpha. I've got to just make this table a little bit smaller. And what table do I have here? I've got the chi table, so I've got to go and look at all my tables and see which one is the table that I need. Now this is F at 0.05 alpha, but I want to point out to you again, whenever you do this example, sometimes we're in a rush to do it and we forget to look what the alpha is of the table that we need to use. So there are many F tables, so maybe when you do approach an example, you are faced with doing an example like this, you open it up and you'll see F table, and we forget to actually make sure that the alpha is the alpha that we're looking for. So in this case, this is the F table that we're going to use. And we'll look at the degrees of freedom. The degrees of freedom for MSA is 3. And so we're going to use 3 F crit, and I'm going to use a colon there, 3, so I'm going to look for 3 in my numerator, and MSE's degrees of freedom is 48, so 48 in my denominator. And when I go back to my table, I find 3 in my numerator and 48 in my denominator. Now you'll see here there isn't actually a 48 in my denominator. The closest I have to that is 40. Well, I've got 40 and I've got 60. So the closest one to my 48 would be 40. So it would be 2.84. This is the value that I am looking for. Using 3 in my numerator and 40, which is the closest to 48 in my denominator. So that is how I read off my F table. And this is only an upper level. So the F crit upper, obviously it's just the one, is 2.8. I've run out of space here. 2.84. My comma is not that obvious. So then to conclude, I've now calculated the test statistic. I've determined the relevant critical value at alpha 0.05. I've got to state a conclusion, and my decision rule is if my test stat is larger than my upper critical value, then I'm going to reject my null hypothesis. So in this case, I'm going to reject my null hypothesis, and I will state my conclusion as I state all the conclusions to an hypothesis test at 0.05 level of significance, or 0.05 alpha. There is significant statistical evidence to state that the mu, or the means, the averages of all of the levels of the earnings brackets are not equal to each other. And we therefore we reject the null hypothesis, and we therefore accept the alternate hypothesis. So you'll say something along the lines of that, but state 4 facts, and there's enough information there for you to state 4 facts, namely the level of significance, the fact that you have significant evidence based on your sample, and then you're going to reject the null hypothesis and you're going to accept the alternate hypothesis. And then when we do the rest of the sums, or the rest of the questions, when we answer the rest of the questions, we'll answer it in exactly the same way. So let's see, do I have my pen? No, I don't have my pen. Let's get my pen back. And so we'll do it in exactly the same way. The null hypothesis for factor B, and factor B is remind myself again, the department. So the department of the premier, the department of, the next one is the department of education. I'm going to just put education there. Department of health and department of agric. And then my alternate hypothesis would be of departments not equal. And then my F statistics, MSB is 3.88048. Excuse my handwriting, it's a little bit difficult on the graphics tablet. And MSE is 1037. Let's erase that. Sorry, a little bit of finger trouble there. Where was I? 9271. And my answer for the F test, you could also write F stat, is let's see, 373. 0.8689. So that is my test stat. And then to read off the F table, I would do it in exactly the same way as I did the previous one, or the first hypothesis. Degrees of freedom, sorry, let me make that a colon instead. Degrees of freedom 3 in my numerator and 48 in my denominator. And we've just done that previously. And it's coincidental. It's because the number of groups in factor A is the same as the number of groups in factor B, but my critical value will be 2.84. And then I'll conclude in the same way. I would say because this test statistic is greater than the critical value, at 0.05 alpha, there is significant statistical evidence based on the sample data to say that the average earnings between the different groups, so departments in the government, is not equal to each other, and in turn we accept the alternate hypothesis, which says that they are not equal to each other. We reject the fact that the null hypothesis that they are equal to each other. So you just state that in a nice, eloquent way, and just ensuring that you state all 4 facts. Then we go on to do the next hypothesis test, which is the interaction. And so the interaction hypothesis would be that there is interaction between factor A and factor B. So state the name of the final test. So this is worth 1 mark. Please remember to read the question. So the first thing you need to tell me is interaction. So 3.1, before we go, interaction between factor A, and factor B. And then 3.2 is state the hypothesis, and the null hypothesis would be that, I've just lost my pen again, sorry, that there is interaction. Between, continue to just say between the earnings brackets and the government departments. I'm running out of time, so I don't want to be writing that. And the alternate hypothesis is that there is no interaction. I've only got 3 minutes left. No interaction, but please do write interaction between the earnings brackets and the government departments. And then when it comes to the F test statistic, which is the next thing, we do the very same thing. So F test is equal to 40983. We've calculated all of that over 5 over MSE, which is 1037.9271. And the answer for the interaction hypothesis, null hypothesis, is 39.48. Let me make my comma look a bit better there. 4859. And I've just got to excuse that bad looking comma over there. Now my critical value, we do the very same thing. We look at the degrees of freedom, which is 9 in my numerator. This is a different one. The degrees, in my denominator, the degrees of freedom for MSE stays 48. But so in this case, we'll have a different critical value. And when we go to our table, we'll look for 9 down the top. But we've got to go to 40 again. So we are sitting with a critical value of 2.12. So we'll write that down, and then of course we will use the same decision rule, 2.12 decision rule. This is greater than the critical value, and therefore we are going to reject the null hypothesis at 0.05. We're going to reject the null hypothesis, which states that there's interaction between the 2 factors, and we will in turn accept the alternate hypothesis, which states that there is no interaction between the 2